Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam, sir.
Alright, alhamdulillah. Please on your camera. Before we go further, let's recite Al-Fatihah. Bismillahirrahmanirrahim. Alhamdulillahi Rabbil Alamin. Ar-Rahmanir-Rahim. Maliki Yawmiddin. Iyyaka na'budu wa iyyaka nasta'in. Ihdinas siratal mustaqim. Siratal ladzina an'amta 'alaihim ghairil maghdubi 'alaihim waladdallin. Right, now we still continue of chapter 3 about zeros of polynomial. To remind you again that this Thursday, you are going to have open book test. You are going to have open book test during the lesson time, during the class time. So class on Thursday, 8 o'clock until 10. Do you think what time do you want to have test? What time you want to have test? Is that okay?
How about 9, sir?
9
o'clock.
Right. So this Thursday is like this. This Thursday. 9 o'clock. You see your Google Classroom. I will put the question there. Then you answer. You just give it to me. You answer and then you submit. The duration for answer is 30 minutes. So more or less 5 minutes, 10 minutes for you to submit, to convert to PDF file like last time, right? Understand? Is that understand? Any problems?
No, sir.
Okay, so this Thursday, you just go straight, 9 o'clock, you go straight to Google Classroom. No Meet. You go straight to the Google Classroom. It's okay. And then you answer to me in 9 o'clock. By 9:30, you finish answering and then you send it to me. You go straight to Google Classroom at 9 o'clock. 9 o'clock will appear the question in your Google Classroom. You start the answer. No Meet. No Google Meet. Right. Is that clear? Not like same like a quiz last time, right? No, it's different from where you have to open Google Meet and then you wait for the question in Google. So now straight you go to Google Classroom at 9 o'clock. So we don't have lesson at 8 o'clock, right? So, but make sure that by 9 o'clock you're ready. You're ready to answer the questions of the test. Is that clear?
Clear, sir.
Okay. Now, we continue with the chapter 3 about real zeros of polynomial. When we talk about zeros of polynomial, zeros here does not mean that zero. Zeros here meaning that zeros of polynomial. which make the polynomial number, which make the polynomial zero. That's the meaning of zeros of the polynomial. Number which make that our polynomial zero. That's the zero of polynomial. Not number zero. Not number zero. Not number zero. Whatever number which make polynomial zero can be number 1, can be number 2, can be number 3. Not necessarily number 0, which make that our polynomial zero. Okay. When we talk our polynomial, polynomial normally represented by px.
Sir.
Yes?
I cannot see.
Can you see that?
No.
Huh?
Okay.
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 Polynomial normally we represent by px, polynomial. So when we talk about polynomial, this polynomial must have zeros of polynomial. Zeros of polynomial, something that number which make our polynomial zero. What are the number which make our polynomial zeros? And number which make our polynomial zero can be more than 1. Depends on the value of the polynomial. Depends on the polynomial. So when we talk about zeros of polynomial, they might be real, a real number. They might be complex. They might be positive. When we talk about real number, they might be positive zeros of this polynomial. They might be negative zeros of this polynomial. And how many of them, of the zeros of the polynomial, they are rational, they are irrational. Now, we look at the multiplicity. Multiplicity of polynomial. Multiplicities of polynomial. Multiplicity of zeros, of zeros of polynomial. Multiplicity of zeros of polynomial, right? So one polynomial maybe can be written like this, like x plus 3, can be x minus 1, x minus 1, written in factored form, which when we expand this, we can have, what is the degree of this polynomial? What is the degree of this polynomial? What is the degree of this polynomial? What is the degree of this polynomial?
3.
3. Yes, 3 degree of this polynomial, because when we expand, it's going to start with x to the power of 3. When we expand. So degree of polynomial depends on the highest power of x. Since the highest power of x is 3, so degree of this polynomial is 3. Right. When we talk degree of the polynomial is 3, degree of px is 3, meaning that factor also 3. Factor of polynomial, factor of px is also 3. Because factor of polynomial depends on the degree of polynomial. Factor of polynomial, or we can say zeros of polynomial, 3. Right. Understand? Zeros of this polynomial will be 3, which means that 3 numbers. when we talk about three numbers, not necessarily that those three numbers, they must be different. If you look back at this polynomial, what make these polynomials zeros of these polynomials? What zeros of the polynomial? What zeros of polynomial? What is the meaning of zeros of polynomial? I said in the early part of the class today. What is zeros of polynomial? Huh?
Number that make polynomial zero.
Number which make polynomial zero. So number which make polynomial zero is -2, right? One of the number which make polynomial zero. Yeah, because when you substitute -2, it's going to be 0 times x minus 1 times x minus 1, 0. Yeah. Another number which make this polynomial zero is 1. Because when you substitute 1, it's going to be 0 times x plus 2, 0 times x minus 1 is also 0. Another zeros of this polynomial also 1. When we substitute x with 1, we get 0 times x minus 1 times x plus 2, 0. So how many zeros of this polynomial? How many? 3. And when we look at the zeros of this polynomial, these two numbers, 1 and 1, repeat. This we call the zeros of polynomial has multiplicity 2. These zeros of polynomial has multiplicity 1. We have 3 zeros. 3 zeros, as I said earlier. If you remember that earlier, those 3 numbers to become zeros of polynomial, even though 3, not necessarily they are 3 different numbers. If you look here, we only have 2 numbers. But 3 zeros. 2 numbers, but 3 zeros. Why? Because these numbers repeat. Multiplicity 2. In some cases, maybe number repeat 3 times. In some cases, maybe number repeat 4 times. Depends. That's why when we talk about zeros of polynomial, not necessarily that zeros of polynomial same as that number. If we say how many zeros of that polynomial? 4 zeros. We're going to have 4 different numbers. Not necessarily. Maybe when we talk about 4 zeros, but only 2 numbers. Why? Because those 2 numbers have multiplicity 2. Is it clear? When we talk about 6 zeros, we only have 2 numbers. Why? Because each number has multiplicity 3, for example. We may have a case that we have 4 zeros and 4 different numbers. But when we say 4 zeros, not necessary that 4 different numbers. If you try polynomial, that polynomial have 4 zeros, for instance. You try, you get only 3 numbers. You say, oh, maybe something wrong. No, not necessary. Because you look here, 3 zeros, but only 2 numbers. And number of zeros here depends on what? Factor of polynomial. Factor of polynomial depends on what? Degree of polynomial. How to know the degree of polynomial? Highest power of x. Clear? Any questions? Then we have what we call rational zeros theorems. This only when for real zeros. For complex zeros, no. Okay, we have what we call rational zeros theorem. Rational zeros theorem say that if polynomial px, which is a n x to the power of n, this is the general form of polynomial. A n minus 1 x n to the minus 1 plus 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 until a0. And this polynomial has integer coefficient. Only integer coefficient. If the coefficient is not in form of integer, cannot use rational zeros theorem. Then rational zeros of px are plus minus c over d. What is c? C is factor of a naught. D factor of an. P factor of a naught. P factor of an. Then C over D. So the possibilities of zeros of the polynomial, when we talk about real parts, come from C over D. And remember the plus and minus. Plus and minus C over D. Plus and minus C over D. Okay. So that's the way how to find the possibilities of rational zeros of polynomial. Possibilities of rational zeros of polynomial. Okay. Fine. And now we want to create polynomial. Find a polynomial of degree 3 with constant coefficient 12. and the zeros are minus 1 over 2, 2, 4. Find a polynomial of degree 3 with constant coefficient 12. Remember that constant coefficient is 12. And zeros of polynomials given as minus 1 over 2, 2, and 4. Right. We want to write polynomial px coefficient zeros minus 1 over 2. So in this case, this polynomial have 3 zeros. Why 3 zeros? Because degree 3. Because degree 3. And what are those zeros? These are those zeros. Minus 1 over 2, 2, 4. Okay. Given that constant coefficient is 12, meaning that A not equal to 12. Okay. When we want to write these polynomials, the zeros of polynomials minus 1 over 2. So x minus 1 over 2, x minus 2, x minus 4. But we don't want what is the leading coefficient. We just say A. We just write A as leading coefficient. So we write down polynomial of degree 3 with constant coefficient 12. Constant coefficient 12. Remember that constant coefficient, not leading coefficient 12. Zeros, the zeros are minus 1 over 2, 2, 4. Right, minus 1 over 2, 2, 4. It's like the A, x plus 1 over 2, x minus 2, x minus 4. Expansions A, x square, you multiply these two first. X square minus 2x plus 1 over 2x minus 1 multiplied by x minus 4. How do you understand that this? How do you understand that this? We multiply these two. Look at this. A x square minus 2x plus 1 over 2. What do you get? Minus
3 over 2.
x minus 1, x minus 4, a multiplications. We get x cubed minus 4x squared minus 3 over 2x squared minus 6x minus x plus 4 Is that correct? X squared times x squared times minus 4 minus
So I think it's positive 6x.
positive 6x.
The right one. 6x.
Where is it?
Yeah. I think it's positive.
Positive. Okay. The rest.
Sir,
Yes.
x cubic minus 11 over 2x square plus 5x plus 4.
X cubic minus 11 over 2 plus 5x plus 4. Like that.
Yes.
Okay. Now we want to find what is supposed to be A. Okay, when we multiply, we get ax cubed minus 11 over a over 2x squared plus 5ax plus 4a. So for A, this is constant coefficient. And constant coefficient is given as 12. A constant coefficient is 12. So A is equal to A equal to
3.
3.
3. A equal to 3. Therefore, Px can be written as 3x cubed minus what? 11/2, right? Times 3 is going to be 33. X squared plus 15x plus 12. This is Px. This is questions want us to create polynomial. And the polynomial that we want to create is polynomial of degree 3 and the constant coefficient given as 12. So we use the value of constant coefficient here, which is 12, in order to find what is A, because we do not yet what's supposed to be our leading coefficient. So we use constant coefficients in order to find leading coefficient. So we get leading coefficient is 3. Leading coefficient is 3. Right. Leading coefficient is 3, and also zeros are -1/2, 2, and 4. So the process of us to create polynomial, we get zeros, 3 zeros, 3 different zeros. This polynomial have 3 zeros, and those 3 zeros become 3 different numbers. Unlike the previous one, as you see that we also have 3 zeros, but 2 numbers only. 2 numbers only.
Sir,
Yes. Yes.
is the leading coefficient is the total number of zeros?
Leading coefficients, the one lead. In this case, we do not know what's leading coefficient.
I don't understand, sir. Where can I get 4A?
4a because we multiply. This is Px. This is Px. This, all this. When we expand, we get ax cubed minus 11a/2 x squared plus 5ax plus 4a. Like this. So we don't know what is a. Or a here is leading coefficient. In this case, yes, definitely a is leading coefficient, but we don't know what is a. We can find a because it's given that leading coefficient is 12. So we will say for a equal to 12, a equal to 3. So when a equal to 3, we substitute back 3. That's why we get this. Okay. So when a is equal to 3, is coincident with zeros also 3, but nothing to do with the number of zeros. Number of zeros depend on what? This degree. Degree 3. Then degree 3, A not necessary 3. But in this example, A we found that 3, but not necessary. In some more case, maybe A is 5, A is 4, A is 2. Depends on the value the question gives. I do not take for granted that A always 3. Leading coefficients is always 3. No. Do not take for granted leading coefficient is a number of degree. No. Number of degrees same as number of zeros. And number of zeros, let's say number of zeros, let's say 3, not necessarily that 3 different numbers. In this case, yes, we have 3 different numbers. But if you remember, if you look at the previous example, we have 3 zeros, but 2 numbers only. Why? Because the multiplicity. Because the multiplicity. Right.
Sir,
Yes.
in this example, is it we use the formula rational zeros of S plus
No,
minus?
not yet. Not yet.
Oh, okay, sir.
We don't use yet. Formula of rational zeros theorem. No. See already, not yet. In this example, just example to create polynomial. To create by polynomial by all the information given. No, we don't use the rational zeros theorem yet. So don't be confused with rational zeros theorem. Definitely, now I did not use the rational zeros theorem for this example. This example is just want to show that same as the early stage today, the number of zeros, degree of polynomial, and create polynomial. About constant coefficient and leading coefficient, I think you're supposed to know before. The previous lesson. What does it mean by constant coefficient? Constant coefficient is the last one. The last one in this case is for A. And given that for A is equal to 12. Why? This. Not necessarily 12. Sometimes in the question, given another number here. When another number here, definitely A will be another number. You get it? Rational zeros theorem? No yet. We do not use yet. Okay. Find the zeros of Px, which is Px is x power of 4 minus 5x on 3 minus 5x power of 2 plus 23x plus 10 using rational zero theorem. Now we use rational zeros theorem. In this case, we want to find the zeros. You see the difference from the previous one? The previous one, not to find the zeros. Zeros given, we want to create polynomial. This one polynomial given. This polynomial. We want to find zeros. And the way we want to find zeros is by using rational zeros theorems. It does mention here using rational zeros theorem. Right. Rational zeros theorems say that probability to get zeros is plus minus C over D. So what is C in this case? C.
Factor of 10.
Factor of 10.
10.
What are they?
1,
1,
10, 2,
2,
5,
5,
10.
10. D.
Factor of x power 4.
Factor of x to the power 4.
Factor of 1.
Factor of 1. Possible, right? Possible rational zeros. They are what?
One.
1 plus
2.
minus, right?
Plus minus.
1,
2,
2,
5,
5,
10.
10. We have possible rational zeros here is so possible rational zeros 1, 2, 5, 10, minus 1, minus 2, minus 5, minus 10. Right, that's only for the possible rational zeros. and the zeros, that's possible rational zeros. But still, we need to find the zeros of polynomial. This polynomial have how many zeros? Has how many zeros?
4.
4 zeros. And the possibility of those zeros come from those numbers. Right. But we still need to find the zeros. Remember back the certainty divisions. Among those possibles, which make the polynomial zeros, the possibility, when we talk about certainty divisions. Right. Okay, I stop the sessions today. And remember that. And the one more. This Thursday, you go straight to Google Classroom at 9 o'clock. You answer that. And remember that this Friday, we have a lesson at 5 o'clock. We have a lesson at 5 o'clock. After you finish Usrah, right? We have a lesson at 5 o'clock. Bear in mind that this Friday, we have a lesson at 5 o'clock. Right? You get it? You get it?
Yes, sir.
Yes, sir.
All right.
Yes, sir.
So I stop the sessions today. Is Tasbih Kifara and Surah Al-Asr.